Thank you to all the attendees for taking time on your day to come attend not just Tech Jobs Fair, but also my talk. So thank you very much for being here. So when I was thinking about what to talk about here, one very obvious candidate was like, I'll talk about InVideo and introduce the company to you and all. But I figured at a jobs fair, I might talk about something that's a little more relevant to you. So I'm going to talk about how to manage your technology career, or how to manage your career as a technologist. All of you all are here, so I'm assuming you all take a keen interest in maximizing the outcome from your career. And so I'm here to share with you some of the things that I've learned over the past, how to build a career in tech. So if it's all right, I'd like to present my screen now. Okay, I get a few thumbs up, so I'm guessing you all can see my slides. That's great. So let's start. So the title of my talk is Don't Get Eaten, Career Management for Software Developers. And that might be a very strange thing to call a talk. What does don't get eaten mean? And I'm here to explain to you what's going on, right? So my first slide is a quote from Erwin Schrödinger, the quantum physicist. And he said, the organism feeds on negative entropy. So one of the things that we see always going on Earth, right? So Earth gets its energy. So y'all are all technical people, so I'm not going to explain what entropy means. Entropy is a measure of disorder in the universe, right? But on Earth here, we find negative entropy. We find orderliness and the beauty of creation and so on. And what's going on here is that the energy of the sun lands on Earth, and some living thing takes that energy and turns it into life. And when we started, we were just single cellular organisms in a vast primordial soup. But over time, we kept feeding on things, getting more and more complex. First, we would feed on sun and some chemicals, and then we would feed on each other. And all of evolution started off from this single cellular organism. At some point, our ancestors left the ocean, came onto land, continued on this journey of evolution. And at some point, humans, in fact, Homo sapiens, invented this thing called abstract thought. Well, we didn't invent it, of course. It was given to us by this process of evolution. And funnily enough, this process of evolution continued in the realm of abstract thought, where ideas consistently kept feeding on simpler and simpler ideas and becoming in turn more complex. And that we see is the universal rule of how life progresses. And I find this a useful vantage point from which to look at one's career, because one's career is part of one's life, and one's life is part of this entire process, and it is driven by the rules of this process. And the one fundamental rule of this process is that life always feeds on things that are simpler than itself, and using this, it becomes more complex itself. And you can see our own ideas have become so complex that the most valuable companies in the world don't make anything quote unquote real anymore. They don't make anything material, like Facebook, Netflix, so on and so forth. These are all companies whose products are purely in the mind, right? And so we find that this evolution of life and complexity has brought us this far. Somehow, somewhere along this line, you decided to program a computer, and so you've become part of this process as well. And so to think about your career is useful to understand this big picture of what is going on. And so I'll say it again. Life always feeds on things that are simpler than itself and uses that to become more complex. And if you want to not get eaten, your job is to become as complex as you possibly can, right? This is the 30,000-foot view of what a career looks like in the modern day and age. But what does it mean, right? This is a very philosophical view, but what does it mean? So in order to understand how this affects us, let's look at what is commonly known as the career ladder, right? So, and essentially the career ladder, like every company has got like different levels and different names they give it: SDE 1, 2, 3, staff engineer, principal engineer, so on and so forth. And it gets pretty confusing along the way, but essentially you will find that the job roles break down into this. At the lowest level, when you're just a junior or an intern, you not only do you get told what to do, you get told how to do it as well. After a while, they stop telling you how to do it and they just tell you what to do. After that, they stop telling you how to do it and ask you how to do it instead. And this is the point at which you're starting to become, let's say, an individual contributor or a staff engineer or something like that. Above that, you get asked what to do and how to do it, and this is essentially the director level in any company. And then later on, no one tells you anything. You're only given goals, and you have to figure everything out yourself. And kind of this is the mapping that you get at the start of your career. You'll start off as a junior software engineer, and as you go through these levels, the kind of conversations that you have at work or professional conversations tend to go from being told precisely when and how to do something to nobody telling you anything, right? And so if you want to understand where you are on this ladder, it doesn't matter what your designation is, right? Eventually, you will, most of your conversations, you will be able to categorize into something like this. And that's how you decide what level you are at and what you need to do to get to the next level, right? And so the career ladder is not actually a ladder, it's an onion. Actually, it's an inverted onion. At the innermost level, there are solutions, and you deal in solutions. You get told a solution and you have to implement it. One level higher, you get to deal with problems. You get told a problem, you need to find a solution and implement it. And later, you are only given goals. And you have to find out what problems adequately relate to this goal, what their solutions are, and how to move closer and closer to the goal. Is that clear so far? Give me a thumbs up if you're still here. One person. Okay, I see a few thumbs up. Thank you so much. Great. So now along this line, along this journey, you will. So who here is a video game player? Give me a heart if you love to play video games. All right, great. I love it. So you all know, obviously, the concept of a boss, right? The boss is the villain at the end of every level that's going to prevent you from getting ahead to the next level. And in this journey of your career, you will meet 3 bosses. Okay. Extra marks and straight hire for anyone who already knows the names of these bosses or who has fought them before, right? But in my talk, I've given them different names from their actual names. And the bosses are as follows. The first boss is computation. The second boss is value. And the third boss is meaning, right? And now I will explain to you what fighting each of these bosses means and what it wins you in the end, right? So the first boss is computation. Obviously, if you're going to build a career as a software engineer, you need to get good at computation, right? In the end, our programs tend to become so complex that it's really, really hard to write them safely and to maintain velocity as the program becomes bigger. And over time, people have spent a lot of time and effort and science and mathematics to figure out how to write safer and safer programs that can deal with complexity and so on. So at any rate, I know I have interviewed hundreds of developers. I know there are many developers here who in our industry who don't actually know how to program, who don't actually understand computation. Don't be one of those people, right? At the start of your career, your most important enemy is computation. And it's not an enemy so much as a kind of force of nature. You have to understand it. You have to understand the fundamentals. And I'll give you a few big ideas in computation that you might consider studying. One of the most important big ideas in computation after the invention of C and of interpreters and so on and so forth, but when we come to the higher level languages, one of the big ideas in computation is a language called Lisp. Today, modern day Lisp is known as Clojure. It's a Lisp that runs on the JVM. It's a beautiful language. And the big idea that Lisp brought to the table was that of homoiconicity, which means that all the symbols in Lisp, whether it is program or whether it is data, like we are used to having data look different from programs, but in Lisp, everything is a list, whether it's a program or data, it is just a list. And this allows for crazy types of meta programming where you can have programs that write programs and so on. So Lisp is a very, very powerful set of ideas that you should at least be familiar with. There are certain languages today, and like these three big ideas, they all appear in all the languages that we commonly use, right? So for example, it could be argued that JavaScript is a Lisp because of the way it handles higher order functions, because of the way it does meta programming and so on, right? Most dynamic programming languages take a lot from Lisp, where you're concerned very much about transforming data and not so much about anything else, right? The second big idea, one which you might already be familiar with, is object-oriented programming. The language that invented all of this was a language called Smalltalk, and Smalltalk is considered the purest implementation of the object-oriented methodology. Stuff that we got later in Java and C++ is considered, well, not really the best implementation of object-oriented technology. The kind of spiritual ancestor of Smalltalk is a language called Ruby. Give me a shout out if you're a Ruby programmer here. Ruby is an absolutely mind-blowing language, and it is half Smalltalk and half Lisp. But some of this will only make sense if you program Lisp and you understand what it is. And the third big idea, which is seeing a very, very big resurgence in this day and age, is the idea of ML. The screenshot is from a language called OCaml. These are statically typed functional languages in the style of Haskell, F#, and so on. But all of these ideas, for example, Kotlin borrows heavily from the ML philosophy of generalized algebraic data types and so on. Now, all of this might sound very confusing, but these are the three big ideas in programming. And if you can get your head around them and try and understand what was the approach that the inventors of this idea took to to solving the problems of computation, then you're very well ahead in your career already. And so this will give you a clue. At the start of your career, go to places that will help you understand computation, right? Trading off an extra 5 lakh rupees for not ever getting to understand what computation means, it will cost you a lot over the period of your career. So at the beginning of your career, you have to focus on becoming very, very good at computation, at being able to write programs that run safely. There are other things that you need to do, like learn how to write tests, do TDD, and all of those other like things that will help you actually understand how to put together a complex program safely. We come to the second boss. The second boss is a boss called value, right? So now value, so you're writing these programs, but eventually the question comes, how valuable are these programs? And if you want to build a business or do a startup or whatever, eventually your program has to have some value, right? And value is bounded by a context, right? So for example, what is the value of a glass of water? Well, it depends. If it's monsoon in Mumbai and there's like plenty of water outside, it's not so much. But if you're in the middle of a desert, that glass of water is worth as much as life itself. And so at the next stage of your career, once you know how to write programs, you get tasked with writing valuable programs. But still, you're given the context in which to write a valuable program. And this is the point where you kind of have to decide whether you want to go deeper into the secrets of computation, i.e. become an individual contributor or a staff engineer, or you want to take the management track, right? And if you take the management track, you might be given a pod, you might be given some metrics that you're supposed to move, you're given a product person with whom you work to solve these problems, and it is your job to understand which program to write precisely to achieve the value that you have unlocked, right? And we've seen today that as a person sitting in a bedroom can create a multi-billion-dollar company. This is called leverage, right? And so the internet and programming and software products give us tremendous leverage as individuals. We can write programs that can reach the entire planet, right? This is tremendous leverage. But what this is doing, right? Getting good at computation actually gives you a longer and longer lever. And this photo is this is an image of Archimedes, who very famously said, give me a lever long enough and a place to put it, and I will move the earth. So there is no limit to the amount that you can achieve with leverage, right? But as you understand Archimedes' problem, he needed a place to put it. He needed to decide where to put that lever to move the earth. And once you get good at computation and you move from computation to generating value, this is the question that will be at the top of your mind always. I have a long lever, but where do I place it? How long should the lever be, right? And where should it be placed? These are the kind of ideas that we will have to deal with. And then later, beyond that, no one actually tells you anything. And if you think about it, like humans, we are the only ones in the entire universe. Human consciousness is the only thing capable of ascribing meaning to things, right? And meaning is the toughest boss because there are no clues. He gives you no clues as to where he is and how to kill him. But but eventually, you're going to have to figure out what kind of value you want to create, right? What do you want to be in the world? What How do you want to leave the world a better place? How to build a business in a particular niche or a particular segment? These are all the kind of questions that have to do with meaning, right? This effort, this value, what does it actually mean in the end? And at the VP engineering and at the CXO level, mostly we are dealing with concepts of meaning, right? What are we building? Who are we building it for? How do they get value out of it? And of course all the lower levels. So it's an onion. You got to eat all three layers of the onion before you can uh, kind of claim to say that you had a good career, right? And so what I would say to you is, this is the biggest advice I can give you, especially at the start of your career, is you should work someplace that cares about your career, right? And I'll definitely pitch InVideo, because at InVideo we work on a very, very complex problem of building a video editor in the browser, making this performant, making it safe, being able to iterate on it without creating bugs elsewhere in the program is pushing the limits of computation. We have an excellent team who will be able to guide you in your battle against the first boss. At InVideo, everyone cares about the value they are creating. All the engineers know all the dashboards that are relevant to them. They know the feature that they pushed last week, what it did for users, what it didn't do for users. And so even at this early stage of your career, we are teaching you to be sensitive to value. And very often, not very often, each time we begin a new feature, everyone from the engineering team is asked, is there a way to do this cheaper? I.e., how can we give the same value for less effort? And you can say we are an engineering first company, right? And we all are, myself included, constantly working to make sense of the world. What is this world? Which direction is it headed in? Which direction is video headed in? Which direction are our users headed in? And how can we best serve them? And one thing I can tell you is that for us, making the world a better place by empowering creators to tell the stories that they want to tell is our mission, right? And so if any of this sounds good to you, I can promise you one thing. One of the ways I judge myself as an engineering leader is by seeing where people who worked for me ended up in their life, right? This is one of the ways I judge my impact in the world. And so if that sounds good to you, I would definitely suggest that you come work at InVideo. And it's 20 minutes and I had 20 minutes. So thank you very much again for your time. I don't know, Urvashi, if we can take questions. I'm happy to take questions. Otherwise, at the InVideo booth, there is a table called CTO table. You can come and chat with me over there.
Thank you for the informative and interesting talk, especially giving the example of onion. Really liked it and really appreciate you taking time off for this wonderful talk. We can have the question and answers right now.
Okay,
So
sure.
if you have any questions, just raise your hand and I'll put you on the stage. Then you can just ask the question on your own. Let me see. Okay, meanwhile we check. I have one question for you. That's something I personally also interested in, is that
Sure.
how to keep the motivation on fire when building a business, especially when you're struggling to get it right.
Well, most people who end up, like, there is a particular kind of software engineer who just loves programming, just
Mhm.
loves programming, right? And I know we've all been there. Some of you in the audience will also have been there, where you're programming and you lose track of time, you lose track of everything because the problem is so this thing. Now, this is of course not sustainable, right? And so we work at what is called an artist schedule, right? When you're obsessed with a problem, you work obsessively on a problem, and then when it's done, you take some time to recharge before picking up the next problem, right? And it's my job to make the problems meaningful and to make sure that they're successful, because nothing demotivates an engineer more than building something that never reaches users, right? Projects that get cancelled halfway, projects that halfway through get decided that this is either not worth building, or it was the wrong thing to start building in the first place. So we
Mhm.
work very hard at the meaning and value levels to make sure that projects do reach fruition and do reach users and do complete that feedback loop, which keeps the motivation going.
Cool. Yeah, makes sense. Cool. We have another question here.
See,
Um,
I can understand the temptation. I can also understand that many workplaces are toxic, right? Uh, So it kind of depends on how many of these stints that you have. Definitely, if there are 3 or 4 such short stints, you're either poor at choosing where to go work, at judging what is a workplace that suits you and your style,
mhm.
or you've just been extremely unlucky, right? So so I would definitely say that you should go work at places where you admire the people who work there. This is the biggest way to avoid a toxic workplace, because everything else over the long run doesn't make a difference, right? That extra bump in salary, unless of course you have a real financial situation that you need to deal with, then of course you must maximize where you need to maximize. But if that's not the situation, you must go work at places where you admire the people that you work with, and where you can learn. Because if you are unable to, if your value system is just purely based on money, then it's no fun working with you, right? People can't depend on you, they can't trust you, and if they can't trust you, they can't open up to you, give you more responsibility, and so on and so forth. And that's not a fun way to run your career either. That's the advice I would give you. So I understand some people end up in toxic workplaces. They're unlucky, so it's not a deal breaker, but definitely all other things being equal, it would put you at a disadvantage.
Cool. Thank you. Um, and do we have another question here? Just a sec. Yeah. So I'm gonna put this person on the stage. Guys, what are the thoughts on the future engineering roles, especially for the current project managers or
Yeah,
people?
you might notice in my talk I didn't talk anything about technology. I talked about computation. Computation is an abstract knowledge, and its manifestations keep changing. Today you have the JVM and Java and Kotlin and all of these new languages and TypeScript, but these are all essentially based on the fundamentals of computation. And uh, so that's why I say get good at computation, not at programming. Programming is what you do with a programming language. Computation is one layer of abstraction below it. It is like, do you even understand why this programming language is structured the way it is? What are the trade-offs it's made? What power does it give you? How to use that power to write safe programs? These things don't change. So everything, AWS, Google Cloud, Kotlin, TypeScript, CoffeeScript, all of these are essentially illusion, what the Buddha called Maya. Yeah, you live in it and it is your day-to-day experience, but it is not reality. The reality is computation. If you get good at computation, that's level one. And of course, project management is extremely important, because when you have to deliver value, like I said, value is bounded by a context. If you have to get something done before a regulator puts you in jail, you have to get it done before. And so project management is important, because time is the only currency we have, right? Especially in a startup, time is super important. So being able to manage a project so it gets done in time is one of the ways in which you create value for the world. So so there is that. If you would like, I talk about topics like this on my Substack. Is there a way I can paste a link here in the chat?
I
Yeah,
think
let me
so.
just paste a link to my Substack. I will be right back. And I talk about project management as well. I have an approach to project management that is basically based on risk management, and I talk about it on my Substack. You can find the link here. Do come read, subscribe, and I would love to talk more with you at the CTO booth. So come by.
Yeah.
Do we have any more questions, Urvashi?
Actually, we do have a couple of questions, but
Sure.
since we're running out of time, I think we should just cut it here. And I think the link that you shared, thank you for it. And I would suggest everyone to just subscribe there and just reach out to the booth, no? If you have further
Yep.
question and intents and stuff like that. So
See you at the
thank
booth.
you so much again. Yeah, see you at the
Thank
booth.
you. Thank you,
Thank
Urvashi. Thanks,
you.
Tech
Bye.
Software, and thank you all attendees for taking the time. Bye.
Thank you, everyone. Yeah. Bye.